Good afternoon, everybody, including you, everybody else on the watching me on YouTube. Good afternoon. Welcome to a rainy, cloudy Monday afternoon of Chem 170 with your host, me, Dr. White. Now, let me remind you, on Wednesday, I will go through the problem set for Chapter 2, the alkanes and cycloalkanes. I would highly recommend you do it before I do. And if you show up to the actual lecture, if you can, I will entertain any questions you have, any of the problems. I'll go through some of them I think are important that if you haven't done, you should. Now, also public service announcements for me, Dr. White. One, by now or by the end of the week for sure, you should know by memory the alkane names and number of carbons from 1 through 10. You should know propane, 3 carbons, pentane, 5 carbons, octane, 8 carbons. Ooh, I'd like the fancy hand signals. And decane, 10 carbons. You should also know the alkyl groups, methyl, ethyl, isopropyl, and propyl, and butyl, and tert-butyl. And obviously, you should know the rules for the alkanes and cycloalkanes, which I'll go over when we do the practice problems on Wednesday. Wednesday, I'll be doing lab number 1. Lab number 1 is now available, or should be available to you. I'll have to check after class to make sure I did. I'm pretty sure I did. Available for you to download from the assignment area of D2L. You'll have 1 week to answer the questions at the end. And if there are any videotapes, things like that, you should watch. And I'll also go through it on Wednesday. All right, let's get back to work. All right, everybody see combustion of alkanes on your screen? Thank you. All right, now on last Wednesday, I talked about general reactions. This is a general reaction. And any alkane or cycloalkane react with oxygen. You need a spark or heat source, but I'm not going to put it there. You get carbon dioxide, water, and heat. Now, on a test, you might see something like this. Three points each. And you see this compound plus oxygen. The compound is butane, but on a problem like this, I'll never ask you to name that product or count a starting material. Now, let me just remind you, this is a chemical reaction. A and B are the reactants. And I'll also, a lot of times, more likely call them, since I spent most of my adult life in the chemical industry, we call them starting materials. And they're always at the base of the arrow. At the head of the arrow, C, that's the product. Or if there's more than one, the product you make. So what I'm asking you to do is give the products for this reaction. How do you do this? Well, you look at what you're given. Well, I've got oxygen, that's O2. Well, what's this right here? What can you say in general? Well, it's only carbons and hydrogen, carbon-carbon single bonds. It's an alkane. but it also could have been a cycloalkane, a ring. And what do you get? This is something you need to memorize. You get carbon dioxide plus water. And now the question is, what's the product or products? Well, anytime you get an alkane, that's this, you're going to get CO2 and water, carbon dioxide. So the answer is this. And think of the general reaction as your roadmap, how to get to the answer, the products. And the beauty of organic chemistry is we talk about certain types of molecules, they always undergo the same type of reactions in a certain grouping or class, or later on you'll learn that means functional groups, even though the alkanes and cycloalkanes are not considered functional groups. All right. Your turn. What would be the product or products for the following reaction? 3 points each. And when you're done, give me a thumbs up or a thumb side. Oh, somebody's playing with my head. All right. Now, here's what you do. You look at this and say, oh, we've got oxygen. What's CH3, CH2, CH3? Well, that's an alkane. Or it could have been, which is not, a cycloalkane. And if you react it with oxygen, what do you get? Carbon dioxide plus water. Therefore, propane, which is an alkane, oxygen, you're going to get CO2 plus water. In this class, and most of the time in organic chemistry, we don't balance equations. The only time we do, which is not something you'll do in this class, is when we need to know how much of each compound starting material you have to react to make a certain amount of a product or products. And that's called charge weights and doing a procedure, which I have done for both laboratories and more importantly, for chemical plants. You know, how many tons of this do you react with tons of that to make so many tons of a product or hundreds of thousands of pounds? All right, now, can you keep a secret? It's time to show the chemistry instructor's favorite trick on a test. And that trick is put a big, scary molecule. And the same question, give the organic product or products. Now, if you look at that and you don't know how to identify organic molecules and use a general reaction, you look at that and see a big, scary molecule, and you might go, eek. Hopefully you won't go eek on my test. But if you look at this big, scary molecule, which it's not, when you look at it's just carbons and hydrogens and carbon-carbon single bonds. Again, it's only carbon and hydrogens and carbon-carbon single bonds. The line shows you a single bond. And it's an alkane. It could have been, but it's not. A cycloalkane, a ring. And you react either one of those with oxygen. You need a spark, but I don't put that down. And you'll get carbon dioxide and water. So if this is an alkane, it is reacted with oxygen. What do you get? CO2 and water. And again, that's a favorite trick on a test for organic chemistry instructors. Me too. Put a big scary molecule. Well, if you don't know what you're looking at and what you're looking for, yeah, it's big and scary. If you know it, nah, it's not. All right, let's try one more. I should share the fun. And same question. What's the organic product or products of the following? And let me fix one of the carbons here. This looks funky. That's not allowed on my structures. There. Your turn. And when you're done, give me a thumb somewhere up, hopefully. All right, looks like everybody's done, so I can get to work. Well, if we look at there, it's a big, scary, no. What do I have? A ring cycloalkane with some alkyl groups substituents. So this is a cycloalkane. It could have been an alkane, which is an acyclic hydrocarbon. It's not, but the general reaction is cycloalkane or alkane, oxygen, spark, which I don't put down, you get carbon dioxide and water. So therefore, if I react this, which is a cycloalkane, I'll get carbon dioxide and water. And I don't have to balance it because we don't in this class. And that's how you know combustion. Now, what does that mean? If you want to do good on test one, you need to memorize that reaction and know how to use it. Now, how do you learn it? You write it down 5 times and say it 5 times. Cycloalkane or alkane oxygen gives CO2 water. Cycloalkane or alkane oxygen O2, CO2 plus H2O. Hopefully all know H2O is water. If you speak Spanish, that's aqua. If you speak German, that's Wasser. And this is carbon dioxide. Which I'll use that term once or twice more this semester. We'll do some work with carbon dioxide. But you should know water is H2O. All right, any questions? All right, let's move on. I don't have a slide for it, but an important part of organic chemistry this semester is where is it in our daily life? And let's look at hydrocarbons in our life. And I could ask on a test 3 to 5 points, give an example of a hydrocarbon that's in our daily life or you could use in your daily life. Well, the easiest one is methane, which you know as natural gas. And the next time, if you have a gas stove or oven, you're burning methane. Another one, which you should be familiar with, propane. And you use that for your barbecue if you have one. Mine died and I haven't replaced it. I'm not a super big barbecue person. I'm more cook it in the oven type person, but that's my person. I should get a barbecue next year or two again. Obviously, it's not high. Now, if you get more carbons, I'm not going to draw it out. I'll just write the name. You have octane, and that's a major component of gasoline. Now, if you have a lot more hydrocarbons, more carbons in a chain, we have baby oil. Baby oil is a hydrocarbon with lots of carbons in it, and this hydrogen, since it's flammable, not as flammable as gasoline, but years ago in the Chem 170 class, I had this one nurse who was going back for her master's in nursing, and she was a neonatal and natal care nurse, which means taking care of babies and premature babies. And when I talked about baby oil, and I sort of knew it, but she really pushed it into our minds, mine and my students, is she said, we always warn new parents that if they're going to use baby oil, it's flammable, not as bad as gasoline, but pretty flammable. So you shouldn't have any lit candles nearby when you're using it. And also she said at that time smoking, well, people don't smoke around their baby. Now, if you get even longer chains, I'll use the commercial name, Vaseline, also known as petroleum jelly. And because it's longer than baby oil, instead of being a liquid, it's that semi-solid material. And it is also flammable. An old survivalist trick, if you have to survive, one of the important things to have is fire. And how do you start a fire if you're out in the woods or wherever? Well, if you have cotton that you've infused, spread Vaseline over and keep it in a baggie in your backpack, you can take one of those cotton balls out or pieces of it with the Vaseline in it, and that will light up real good. And finally, if you got really a lot more carbons, paraffin wax. And paraffin wax you can find in candles. 50% of the weight of good or high quality candles is made of paraffin wax. And this is a hydrocarbon, really an alkane, that's got a lot of carbons in it. So if on a test, I ask for example of a hydrocarbon or an alkane you can use in your daily life, well, we've got methane, that's natural gas, propane, that's for your barbecues, octane is found in gasoline, Baby oil is a hydrocarbon. I think you know what that's for. And Vaseline is a hydrocarbon. And even more, you have paraffin wax, which is found in candles. And one of the things I like to do is make our class, what you're learning, relevant by show you where in the real world you find this stuff. Because if you just learn a theoretical, that's not fun. Now, if next time you happen to go by a gas station, you'll think, wow, they're selling alkanes. And about half the weight is alkanes and gasoline you buy nowadays. But think about it. Next time you go by a gas station, they're selling organic molecules for your car. All right, any questions? Well, if I go back to here, everybody, can you see the lower left of your screen where it says page 19 of 19? That means we're done with the chapter. So that's why on Wednesday, I'll do the alkanes, cycloalkanes chapter 2 problem set. I'll go through it. Well, you know what that means? It's time for a new chapter and new stuff. So let's go there. First of all, let me close this chapter. Yeah, oh, excuse me. Everybody see on their screen alkenes and alkynes? All right, what's an alkyne? An alkyne is a hydrocarbon that contains a carbon-carbon double bond. And we show a double bond by two lines between two carbons. Double bond, two lines. This is a double bond. Now, I will never ask on a test, but alkenes have the formula CnH2n. I will never ask that on a test or the final. And all of you have each other as witnesses. I've said that. Plus, will be on my YouTube video. I've got to keep to my promise. I always do. So, an alkene, ene ending alkene, means you have a double bond. Now, there's also alkynes, YNE ending, forget about the S for now. Those are hydrocarbons. Remember, hydrocarbons are molecules that only have carbon and hydrogen atoms. And here we have a triple bond, which is shown by three lines between two carbons. So alkynes have the formula CnH2n minus 2. I will never ask on a test or the final anything to do with that formula. But I have been told certain entrance exams where they test you on your knowledge of organic ask, how should I put this? The kind of question I would never ask, because there are better things I can ask you. If you have 5 carbons and you have an alkyne, how many hydrogens? Well, you put 5 in there. 2 times 5 is 10. Minus 2 means 8. Nah, I don't ask questions like that. So, alkynes, double bond. I mean, alkenes, double bond. Alkynes, triple bond. Let's try that again. Alkenes, double bond. Alkynes, triple bond. Now, as I just said a little while ago, it's important to see where the stuff is in our daily life. And this chapter and the number of the next weeks, when we go into new chapters, I'll follow a similar pattern. That is, I'll introduce you to the new functional group. Now we're talking about functional groups, grouping of atoms and how their bond, whether they're in this type of molecule or another one, react and have similar physical properties. And I'll introduce you to it. I'll either initially show you where do you find this in our everyday life, or I might wait a little while. And after I talk about nomenclature, how do you name these, then I'll talk about where do you find it in your everyday life. And after that, we get into the fun part. And the fun part is how do you make these functional groups? And then the real fun part, how do you react them to make new products? And why is that fun? Because those are things you use in your everyday life. Later this semester, I'll talk about how you make the molecules for the soap you use to clean your hands, your clothes, whatever. And I'll talk about a whole lot of other things, some of the molecules in your body, and how they react, like how do you digest them? We're going to get into a lot of neat stuff. But let's talk about double bonds and triple bonds. Now, there's one molecule called beta-carotene. And let me go to Wikipedia. Everybody see Firefox on your screen? Thank you. I think I might have mentioned it, but I'll say it again. For a number of years now, Wikipedia in organic chemistry and other chemistry too, but I know for sure organic has so been heavily policed by people like me and others. I've rarely seen a mistake in here. Now, do not copy this down. Now, this is the line method, which I don't do for the carbons in the chain here, but every bend in a line is a carbon, every end in a line is carbon, like right here is a methyl group. But two lines between two bends, two carbons, double bond. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 double bonds in this molecule. This is called beta-carotene. Do not write it down. And where do you find this? This is the molecule that's responsible for the orange color of a carrot. Next time you look at a carrot, you see its color, that's because of this molecule. It absorbs all the light. Remember, white light coming down in my office or outside in the sun is made up of the different colors of the rainbow. How many remember from high school? Roy G. Biv, red, green, blue, and so on. But anyways, this absorbs everything except the colors that mix to make orange. Now, this is something Mother Nature came up with. And how many of you heard of rabbits have good eyesight because they eat a lot of carrots, like Bugs Bunny? And this molecule, your body breaks down to another molecule called retinal. Wonder where you'd find retinal for your eyes, your retinas. And that helps you. How much, I don't know, but I can always remember Bugs Bunny eating a carrot, so it helped him a lot. And this is responsible. Double bonds in this molecule make that so. So, are we done yet? No. Let's go to another molecule. And that's lycopene. And lycopene is similar. You don't have to write this down, but I thought I'd show you. Similar to beta-carotene with a lot of double bonds, but no rings at the ends with a double bond. And this is beta-carotene. Now, beta-carotene, lycopene, sorry, this is lycopene. And where do you find this? If you look at tomatoes, lycopene, where they show some right here, is the molecule that's responsible for the red in tomatoes and other red fruits and vegetables. Now, I say carrot, red carrots. I don't think I've ever seen a red carrot in my life. Have you? I don't think so, but somebody did. But things that are red, except not everything strawberries and cherries don't. Now, why Mother Nature put that in there, I have no idea. What it does in your body, I don't know. But it's there, and that's what causes tomatoes to be red. I'm going to assume all of you at one time in your life seen a carrot and a tomato, whether it's in a supermarket, vegetable stand, or a salad. Are we done? No. All right, hold on. I got to get something. I'll be right back. I'm back. Should have brought this up earlier. By the way, it's getting dark outside again. If I get knocked off Zoom, I'll try and get right back on. Usually that's happened in the past, bad storms. Now there's a product that I don't get any kickback from, Glugon, and Glugon is a good product to get, the sticky adhesive off things from leftover from tape, masking tape or whatever. And if you look at the label here, contains petroleum distillates, hydrocarbons, and limonene. Ooh, what's that? Let's find out. That's one of the nice things about this course. By the end of the semester, you can read labels of content and look up or know what they are, which is a good thing. Now, everybody see this ring on your screen? End of the line is the methyl group. This dash says the group is below the ring. And notice it's got 3 carbons because 2 ends and a bend. There's a double bond here and 1 in the ring. Now, this is called limonene, and it's responsible for the citrus smell and taste in certain things like lemons and limes and other things, other citrus vegetables, not vegetable fruits. And this has a nice smell to it. Have you ever smelled a product that says, look, this is lemony fresh, and the cleaning product, you smell, wow, that does smell lemony fresh. Well, they put this molecule in there. Also, it has some cleaning properties, which is why it's in here. And one of the things you have to be careful of, advertising from different companies have brainwashed us to think certain things. And one of those is, well, if it smells lemony fresh, it must be a good cleaner. And they put that in a lot just to give it an odor and not enough to help clean. But that's marketing sales at some companies. So let's think about this. Your carrots are double bonds. Your tomatoes have double bonds. Cleaning products, like I showed you, have double bonds. Wow, this stuff's serious. It's everywhere. So an alkene, carbon-carbon double bond. Alkyne, carbon-carbon triple bond. Now, I'm going to turn the switch off for this slide, but just a couple observations. What are unsaturated hydrocarbons? Well, that's a hydrocarbon molecule with only carbon and hydrogen. So I asked you to learn the definition. They have a carbon-carbon double bond or double bonds or triple bond or triple bonds. So alkenes, alkynes are unsaturated hydrocarbons. How did they get that name, unsaturated? Because they contain less hydrogen atoms than alkanes. They have less on. You can add more to it. Now, again, they have either one or more double bond or triple bonds. Hold on one sec. Nope, it's not the President of the United States, so I'll catch it later. I don't think he has my phone number either, but you never know. Bye. I think one more ring in my answering cell phone, pick it up. Thank you. All right. Now, also, and I'll teach you this later, again, switches off for this. The addition of hydrogen gas will convert an alkene or an alkyne into an alkane. You get rid of the double bond, you're left with a single bond. All right. Now, this slide I should have removed. I forgot. So just cross it off. Now, as I said, I'm going to talk about the functional group, and I introduce, say hello to a double bond, an alkene, and a triple bond, 3 lines, an alkyne. So how do you name these? An ENE ending, like you see here, is used to designate a double bond. Now, when there's more than one, I should have removed this. I'm not going to do more than one double bond. So let's take a look at this. Now, what we'll do is select the longest chain that contains both carbons. So we'll start with a double bond, and you'll name that as an alkane. And I don't have it on here. All right, let me go through an example. All right, everybody see my whiteboard? Now, this is very important. Can I have everybody's attention? From now on, when you're looking at an organic molecule, look for what's different. What's not a carbon-carbon single bond or carbon atom or hydrogen atom should get your attention like that. Again, look for what's different, because that's where all the fun is. And if we notice here, look, a double bond. Now, how do you name this? You name the longest chain with both carbons of the double bond in that chain. You name the longest chain as an alkane with both carbons of the double bond in that longest. 4 carbons butane. But for a double bond, drop the ane ending and replace it with ene. Now, you're not done yet. Which two carbons are the double bond between? If we had a longer chain, you'd have a lot of choices. Here, there are two of them. You number from the side of the chain that gives both carbons a double bond the lowest numbers. You number from the side of the chain that gives both carbons the lowest numbers. So 1, 2, I start here, 1, 2, 3, 4. Which is smaller, 1 or 2, 3 and 4? Isn't the math hard? And hopefully I'll pick 1 and 2. And the number that's closest, carbon that's closest to the end of the chain, use that number. Therefore, this is 1-butene. Again, find the longest chain with both carbons of the double bond in it. Name it as an alkane. 4 carbons, butane. Drop the ane ending at the end of butane and replace it with ene. Ene means double bond. And then, what carbon of the 2 carbons of the double bond is closest to the end of the chain? You give that number. In this case, this end is 1. And that's how we got 1-butene, ene ending double bond. And remember, it's very important that you look at molecules now and look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that. I used to snap my fingers, but it's not as loud on Zoom. In the classroom, it's loud, but not on Zoom. All right, your turn. Oh, one thing I forgot to mention, and I'll show it to you in this molecule. How many bonds to carbon? 4. The double bond counts as 2 bonds to carbon. If we look at this, double bond, 2 bonds, 4 minus 2 equals 2, which is why there are 2 hydrogens. If we look at this carbon, it's got 1 plus 2, 3 bonds. 4 minus 3, 1, which is why it has only 1 hydrogen. Now, your turn. What would be the IUPAC name for that molecule? And this is why you have to learn those 2 tables, at least the alkane name, because you use that to name this. And when you think you're done or know you're done, give me a thumbs up. Thank you. It's time for me to move forward. All right, look at this molecule. What's different? Ooh, a double bond. Remember, look where what's not a carbon-carbon single bond or carbon or hydrogen atom. That should get your attention like that. I guess I'm going to be doing a lot of clapping this semester. So we'll be doing a lot of functional groups. All right, double bond. How many carbons in the longest chain with both carbons double bond? Don't know. 1, 2, 3, 4, 5, 6. That's hexane. Drop the ane ending, put, because of the double bond, ene, hexene. Remember, ane to ene. Next, where's the double bond? Well, if I start here, there's 1, 2. The close carbon would be 1. If I start the other way, 1, 2, 3, 4, 5, 6. So the close carbon would be 5. Which to the end, this end? Which smaller number, 1 or 5? Time's up. Hope we all picked 1. So this is 1 hexene. And that's how you do it. And if I look at the clock, we're just about time for a break. So I'll give you a whole extra 30 seconds. And let's take a 5-minute break and come back at 1:55. Come back at 1:55 p.m. For those with an analog clock, that's when the big hand is on the 11. And I'll see you in 5. I'm going to get up and stretch. let's get going. Sorry, I was running a minute late. I just got my glasses from Zenny, not that I get any kickbacks from them, but for many years, if you go back and look at the old Chem 170 videos on my YouTube, you'll see I'm wearing glasses. I'm not now. That's because last November, late November, I had major cataract surgery on both eyes. And if you ever need a great eye surgeon, there's one in Hoffman Estates I use. Email me, I'll give you his name, or you can pass it along to neighbors, friends, or loved ones. But he warned me when I put the new lenses in, which I never had to in the past need reading glasses, but for everything else, like driving and everything, and even now I'd have my regular glasses on. Well, I just got the reading glasses from Zenny. One hint, if you ever use Zenny, have your optometrist measure your pupil distance. Don't do it yourself. I never did. I always had an optometrist. It doesn't change once you get it, but it's a safe thing to do. All right, let's get back to double bonds. By the way, do you think about carrots or tomatoes have double bonds? Well, tomorrow. And don't forget, next time you go by a gas station, think about the fact that they're selling alkanes. All right, we're doing nomenclature of double bonds. Now, what happens if you have an alkyl group? Remember, there are 4 bonds to carbon. Haven't said that in a while. And it's now your solemn responsibility when I'm putting in hydrogens to make sure I'm doing it correctly. This carbon here has 3 bonds to it, 4 minus 3, 1 hydrogen. This carbon has 2 bonds to it, that's double bond. 4 minus 2 is 2. And the question is, give the IUPAC name. Well, I better stop being lazy. Remember, organic chemists are lazy. And sometime on a piece on something else, have you take, you'll see something 3 points each. Give the IUPAC name for A. And there's a molecule. Now, remember, IUPAC means for you, official name, and it really means International Union Pure Applied Chemistry. I think it's cool to say that, but I'll never ask that on a test. So how do we do this? I'll do one, then I'll let you try one. Now, what do? We look for what's different. What's not a carbon-carbon single bond, carbon or hydrogen, should get your attention like this. That gets your attention? And we have a double bond, an alkene. So how many carbons are in the longest chain with both carbons double bond? 1, 2, 3, 4, 5, 6, 7. There's another chain we have to consider. 1, 2, 3, down to here is 4. Which is the greater number, 7 or 4? And time's up. Hope we all pick 7. What do we call the alkane with 7 carbons? Heptane. But for a alkene, drop the A and E ending at the end of the alkane name and replace it with ENE. Therefore, this becomes heptene. Now, which carbon of the double bond is close to the end of the chain, and what number would it have? Well, the answer is 1, because if we go the other way, this would have been 6. So it's 1 heptene. As soon as I say that, that's spoken for. Are we done? No, look what's left over. It's your old friend, the methyl group. And what carbon is it on? Well, this is 1, this has to be 2, this has to be 3. So that's 3-methyl, 1-heptene. Now again, find the longest chain with both carbons of a double bond in it. 7 carbons. Name it as an alkane, heptane. Drop the ane ending, put ene, heptene. Which carbon of the double bond carbons is close to the end of the chain? Give it that number. In this case, it's 1. Then the alkyl groups are just the same as we've done before. The methyl group is on carbon 3, 3-methyl, and you can't see it because it's sort of hidden, but there's a dash there. Let me clean this up. Methyl 1-heptene. Now, if you don't put the dashes in there, I will not take points off. So now it's time for you to have fun. And here we have 1, 2, 3, 4, 5, 6, 9 across, plus on this carbon, we have 3 carbons. Now, I think I might have mentioned I was going to do it maybe today, but I think I'll hold off till Wednesday. This Wednesday, come to lecture or come to my office hour, and I will teach you all my method for eliminating test anxiety during a test. And it works quite well. I've been teaching it for a number of years now. Again, the question is, give the IUPAC name for that molecule. Your turn. In case you forgot, let me open up this file. Key alkyl groups, and let me put it on the screen. Everybody sees key alkyl groups. 3 carbons, you have 2 choices, N-propyl or isopropyl. If it's to the end, it's N-propyl, to the center, isopropyl. And this is a table, hopefully by the end of this week, or next Tuesday or Thursday, a week from this Wednesday, you know this table as good as you know your first name. I assume all of you know your first name real good. And when you're done, give me a thumbs up. Remember, when you're done, one person is already done. I'll wait for everybody else. Give me a thumbs up. Use your emoji. I already got one person done. Those in Florida, you're done, I know. Or if you just want me to continue on, give me a thumbs up too. All right, let's start going. How do you name this? You look for what's different, what's not a carbon, hydrogen, or carbon-carbon single bond should get your attention. And we've got a double bond. How many carbons in the longest chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one chain. 1, 2, 3, 4, 5, 6. That's the second chain. Now the chain that goes like this, you don't count that, because that doesn't include both carbons of the double bond. So we have 6 or 9, which is the greater number. Hopefully all pick 9, and that's no name. Remember, double bond, ANE ending, name it as an alkane, drop the ANE and put ENE. That'd be nonene. I'm sure glad I'm not doing enunciation quizzes. But anyways, so what carbon of the double bond is close to the end? Well, in this case, this is 1, 1. Therefore, this carbon is 2, this is 3. So this is 1 nonene. Now, as soon as I say that, this is all spoken for. And we have this 3-carbon alkyl group. Notice the N carbon is bonded to my chain. That's called N-propyl. And what carbon is it on? 3. So this would be 3 N-propyl, 1 nonene. And that's how you do double bonds, sort of. We'll come back to something important in a little while about nomenclature double bonds. Now, what I have here, number 2, select the longest carbon chain, as I've been doing, both carbons double bond, number it from the end, have the lowest, indicate the position. What I forget about 5, there's more than 1. What I don't have here, oops. We're in a classroom. He'd be waiting while I'm doing this on the whiteboard. All right, now we already did this. Name the alkane with both carbons a double bond and drop the ANE ending and replace with ENE for a double bond. What about a triple bond? And everything else I've already done. So let's look at triple bonds. Now, if we look at this this molecule, and I think we're on D, again, give the IUPAC name. Look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that. And what do we have? A triple bond. Now, let me point out, how many bonds to carbon? 4. How many bonds to carbon? I'm ambidextrous. I can do that with both hands. 4. If we look at each carbon, triple bond, it has 4 bonds. The 3 lines plus 1 more is 4. 4 minus 4 is 0, which is why there are no hydrogens on those 2 carbons. Now, how do you name this? What's the longest chain with both carbons of the triple bond? 1, 2, 3, 4, 5. That would be pentane. But for a triple bond, drop the ANE ending and put in YNE. So pentane becomes pentyne. YNE ending triple bond, pentyne. And when you do the practice problems for this chapter, that will help you learn this. Now, we have how many carbons are in the longest chain. This is important with both carbons of the triple bond. Well, there's only one chain, 5. That's how we got which carbon is closest to the end of the chain. This one. So if we start here, it's on carbon 2. If we started the other way, be 1, 2, 3, which would be the closest. So which is smaller, 2 or 3? Math's really hard in this class. And hopefully all pick 2. So that would be 2 pentyne. Let's go through it again. You look for what's different. Triple bond. How do you name that? Find the longest chain with both carbons of the triple bond in it. In this case, there's only one chain, 5. Name it as an alkane. 5 carbons, pentane. That's why you got to learn that table of the 1 through 10, because nomenclature is based on that. Next, drop the ANE ending. For triple bond, we use YNE ending. Pentyne. Then which carbon is closest to the end of the chain? You number it, and that you get the lower of the 2 numbers. And that's carbon 2 is the first carbon close to the end, and it's 2 pentyne. Psst, 9. And your turn. What would be the IUPAC name of that molecule? 3 points each. And when you're done, give me a thumbs up. Well, one person done. Again, when you're done, give me a thumbs up. And for those who already done, please be patient. I try and give everybody a reasonable amount of time to finish. All right, let's get going. Look for what's different, what's not a carbon-carbon single bond or a carbon or hydrogen atom should get your attention like that. Hopefully it did. Oh, look, a triple bond. How do we know that? 3 lines between 2 carbons. How many carbons are in the longest chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted wrong. 3, 6, 9. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I did count wrong the first time. So 9. What do we call that? No name. Now, a triple bond, you take the alkane name, drop the A-N-E, and put Y-N-E. So no 9. What carbon of the triple bond is close to the end of the chain? 1, 2, 3. We go the other way. 1, 2, 3, 4, 5, 6. Which is smaller, 3 or 6? And hopefully you all answered 3. So that would be 3, no 9. Now, when you have alkyl groups, you name them just the same as we've done in the past. So I'm going to let you see if you can solo on your own. And again, the same question. Give the IUPAC name for the following molecule. 3 points each. And if I write a structure and you're not clear about how many carbons, or you need to write it larger, for me to write it larger, let me know. This is a high-tech whiteboard. I can increase the font like that. All right, anybody need more time? Let's get to it. What's different? What's not carbon? What's not hydrogen? A triple bond. How many carbons along this chain? 1, 2, 3, 4, 5, 6, 7. That's one chain. There's another chain. 1, 2, 3, 4, 5, 6. What's the longest chain? 7 versus 6. Hopefully I'll pick 7. So the longest chain is 7, the alkane name. Hopefully you've learned that table. Heptane. Now, for a triple bond, you take the alkane name, drop the ane ending, and replace it with yne, heptyne. So I'm going to do that. Heptane becomes heptyne, yne ending. Now, what carbon is closest of the two carbons double bond to the end of the chain? This way is 2. If I started from this end, be 1, 2, 3, 4, 5. Which is smaller, 2 or 5? The answer is 2. So you number the chain the way I'm doing it. This carbon is 2, this is 3. Therefore, this is 4, this is 5. Oh, look, as soon as I say, first of all, 2-heptyne, all that's spoken for. And we've got something left over. It's your friend and good buddy, the methyl group. And what carbon is it on? Carbon 5. So that would be 5-methyl 2-heptyne. Any questions? Anybody want me to repeat that, how I got it again? All right. See the triple bond. Find the longest chain of both carbons in the triple bond. The chain across is 7. If we go here 5 and down to the methyl group, that's 6. So the longest chain is 7, heptane. And let me open up something. And hopefully you've learned this table. If not, make that a high priority this week. You should know it. Just thank you. But on the test, you shouldn't have that out. I put secret things in my test to know if somebody's cheating, and they work. Watch out. Organic chemists can be very clever. It's part of the job. But anyways, 7 carbons, heptane. And now, as soon as I say that, heptane, it's a triple bond, drop the ane ending at the end of heptane and replace it with yne, so you get heptyne. Which carbon is closest to the end of the chain? And the answer is, if I start from this end, it's carbon 2. This end, it would be carbon 5. Use the lower number, so it's 2-heptyne. Finally, we have left over, oh, it's your old friend, the methyl group, and that's on carbon 5. And that's how you do it. Boy, this is thirsty work. All right. And we've done all this now. We've done some practice, so we've done that. Now, there's some common names that before IUPAC, organic chemists, or even before they call them organic chemists, have been using these common names. Now, I'm going to only ask on this table you to learn the structure of one of them, this one. But I'll go through, the other one. This is the structure for ethylene. The IUPAC name is ethene. Nobody ever calls it that. And why not a number? Because it's impossible to have two ethene, because either carbon is always going to be one in the name. Since we know it's going to be one, we don't even put it in the name. Now, ethylene, I'll teach you later, way later in the semester, when we get into polymers, you can put a lot of those together, and we have something called polyethylene. And another name for polyethylene product is saran wrap, your kitchen wrap. Now, propylene, and this won't be on a test, and I'll explain why in a second, has this structure. Nobody ever calls that propene. They use propylene. And how someone came up with the common name, I don't know, a lot of them. But they've been in use for so long, people still use them. And I'll teach you, have you ever bought some sort of electronic device like a thumb drive or other things that's in that plastic shell on a card? And you got to spend the next 10 hours trying to open it without damaging it? That's made from a plastic called polypropylene, which is made from propylene. Now, the one I would like you to learn is acetylene. And I'll explain why in a second. And there are two ways I can draw it. And that would be the structure of acetylene. Now, acetylene is the simplest triple bond. Nobody ever calls this ethyne. Y-N-E ending triple bond. Now, if you notice here, the hydrogen on the left is on the left side of the carbon. That's called left justified. And here, it's on the right side. That's right justified. And on the left side of molecules with carbon, you can do either one. I personally like this. My software defaults to this. So once in a while on a test, you might see that. Now, when it comes to common names, listen carefully. I will never ask, what's the common name of a molecule? But I will ask, draw the structure from this name, and I can give you a common name. I will not ask for ethylene or propylene, but acetylene you should know. Ooh, that reminds me. How many of you ever heard of an acetylene torch? Those are those torches you see in the movies where the guys are cutting out the lock from a safe. Or if you've ever been in a body shop, they're cutting metal with the super hot torch. And instead of burning methane or propane, you burn acetylene with oxygen, and it gives a much, much hotter flame that you can melt metal, like steel. Or if you've ever had an old car, which has happened to me years ago, and you try and get the lug nuts off the tire and they won't budge, you go to your local dealer or body shop, and they'll take an acetylene torch and heat up those bolts a little to loosen it up so you can loosen it. One other group, I'll have the switches off. When you have a double bond like that as a substituent, a group on something else, we call that a vinyl group. Just like methyl group, ethyl group, that's called vinyl group. How many of you have ever heard of vinyl floors? Anybody? You ever heard of vinyl floors? Or, yep. Well,
Yes.
they're made from molecules with vinyl groups in it. All right. Let's talk about double bonds again. Let's talk about the pi bond. Now, the word pi, pi, comes from the Greek letter pi. And in math, that means 3.14, but in chemistry, that means something different. Now, listen carefully. Part of this slide, or all of it for now, but I'll explain it in a couple slides better, switches click off. Now, when we talk about a double bond, not all bonds are created equal. Double bond. It contains, when you're each carbon, and this I'll explain, but it won't be on a test, 3 sp squared hybridized orbitals, 1 p orbital. The bond angles are 120. Don't have to write this down. And there's no rotation around a carbon-carbon double bond because of p orbital overlap in the pi bond. Well, what does that mean? Well, let's look at the double bond. Double bond is made up of two different bonds. One is the pi bond, and the other is the sigma bond.
Can you move the sheet, I think, up a little bit?
I'll tell you what, let me do something even better.
Okay.
Big screen. Is this better?
Yes.
Oh, it's time for me to be subtle. Don't you love it when I'm subtle? Hint, know this. Subtle like atomic bomb is subtle. All right. So when you have a double bond, it's made up of two different bonds. One is called the sigma bond, a single bond, and the other is a pi bond. Sigma bonds you don't break. It's very rare. Pi bonds, I can break like that. They're fun to break. They're easy to break, and we break them a lot. So we have a pi bond and a sigma bond in a double bond. They're not the same.
What did you write above the sigma bond?
Which slide?
Where you were at right now,
I mean, the smaller or bigger one?
the larger one. Like the actual what? What's
All
above
right.
the sigma
In
bond?
this right here,
Uh-huh.
that is the Greek letter sigma.
Okay. So it's one sigma?
Mm-hmm.
Okay.
That's a good question. That's sigma. All right. And as always, all questions are good questions. Nasio, thank you for your question. I really practiced that in my life and my class. Let's do one other thing. There you go. Here's a better one. Let's. Looks a little better than mine. Do you see what I have here on the screen here? That's sigma. I like to put a little curly wave on there. And while we're here, okay, and you can just go to Google and put in sigma Greek letter, and I'll do pi. And there's pi. And notice some have the little sort of cap on there, some it's flat. I do it this way normally. That's the Greek letter pi. If you were in a fraternity like Dr. White, all pledges had to learn the Greek alphabet. Alpha, beta, gamma, and so on. All right. So double bond has one pi bond, one sigma bond. Now, next couple of slides, switches totally off, but I just like to show you. If you looked at one of the carbons in the double bond, when it's coming together to form a double bond, you see the gold knobs here or lobes? That's the orbital called sp squared. And you have each one has an electron. You see the blue or orbital or node with a P in it on your screen? Can you see that? Give me a thumbs up if you can see it. That's where there's an electron also. When we talk about orbitals, that's the probability. If I had the power to stop all motion, boy, I'd be strong and powerful, and say everything stops, even electrons moving in atoms. In the blue, that's where you'd find the p electron, and in the gold, each one of those would have in that area somewhere the sp2 electron. And the bond angles between these two nodes is 120 degrees. Again, switches off. Now, when we bring two carbon atoms together, again, switches off, you'll form, first of all, the sigma bond. You see it right here where you have the overlap on the second picture? And their sigma looks a little like mine. I put a little more curly Q on the top, and that's a sigma bond. Now, what's a chemical bond? A covalent chemical bond is sharing pairs of electrons. And each one of the nodes has one, so the sigma has two electrons. Now, each pi has one electron, and when you, each p orbital, when you share it, you form the pi orbital. Do you see the blue here, top and bottom? And so between these two carbons would be a double bond, two lines, but we show it when we're talking about the electrons and where they really are. It's a sigma bond and a pi bond. Now, when it comes to molecules, the carbon-carbon double bond is trigonal planar. Switch is still off. I won't ask on a test. And that's because of the bond angles, and the p orbital holds it firmly. If you look at my model, this is a double bond. Here's a carbon, here's a carbon. And notice they're in the same plane. Forget about these two. The atoms, these two hydrogens, so this was ethylene or ethene, nobody calls it that, I won't. And this carbon and these two hydrogens, they're in the same plane. And that's what we mean by trigonal, triangle. Notice the bond angle here is 120 degrees. Now, unlike a carbon-carbon single bond, hold on, time out while I go get something. I'm back. Now here I have two carbons, one here, in between I've got a single bond. And if you notice, I can rotate this because there's what's called free rotation around a carbon-carbon single bond. Again, switches off, but with a double bond, having both the sigma and the pi, it's locked in place. This is not rotating. I could break it, but then I broke the bonds. No, I'm not going to break my model. But single bond, free rotation, double bond, it's locked in place. And that has profound implications, including certain things that are healthy for you and not healthy for you. Really? Yep. All right, let's go back. And I just realized something. You know, all the double bond examples I gave you were on carbon 1. Let's do a different one. And now let's take into account the bond angle. And this is how. Oh, let's do 2. I'll throw in an extra one free. Let's call this A. Let's call this B. Did I tell you how great a job IUPAC did? They did such a great job of nomenclature, naming rules, that no two different molecules ever have, that I know of, and I don't think it's actually true, ever had the same name. Again, IUPAC has done such a great job that no two different molecules ever have the same name. Well, let's look at A. What's the longest chain? First of all, everybody see the double bond there. Well, even with the bond angle, this is connected to this carbon, connect to this carbon, connect to that. Even though it's not straight across like I've been drawing it, remember it's a chain and you can bend chains different ways. And the longest chain is 4. Butane. It's a double bond. I'll drop the A and E and put E on E. Now, if this is carbon 1, this is carbon 2, and from either side, I could do 1, 2, so that's 2-butene. And that's how we would name A. Did I tell you what a great job IUPAC's done? You never have two different molecules with the same name. Never. Well, let's get on to B. What's different? A double bond. How many carbons is the longest chain? 1, 2, 3, 4. Even though it's bent, they're bonded together. The first carbon is bonded to this carbon, bond to this carbon, bond to that carbon. So 4 carbons is butane. But a double bond, you drop the A on the ending and put E on the ending. Did I tell you how great a job IUPAC did in their nomenclature? No two molecules that are different have the same name. Well, let's continue on. Well, what carbon is the lead carbon of the double bond? Well, if I start here, that's 1, 2. I could start here, that's 1, 2. Uh-oh. A and B are different, but they have the same name. Oh no, what do we do? Relax. Let's look at the slide. And IUPAC knew about this and came up with the concept called cis-trans isomerism. Isomers are molecules that have the same number of carbons, same number of hydrogens or any atoms, but are set up differently. Now, due to no rotation around a carbon-carbon double bond, things are fixed. And instead of using carbons, I took some oxygens because you can see it better. See how, notice if I had a plane right here in my hand, the red atoms or carbons, if they were, are below my hand. That's the second molecule. if I have this, notice the red are below and above, opposite sides of my hand, or a plane coming out toward you. That's called orthogonal plane at a right angle. And what does that mean? It means I forgot to go like this to change the slide. When you have two groups that are the same, one on each carbon of the double bond, we call that cis. When you have two carbon groups or atoms that are on opposite side of the two carbons of the double bond, that plane, we call that trans. So cis, same side, trans, opposite. Cis, same side, trans, opposite. And now let's go back at these two, A and B. Notice if I were to put a plane, like my hand or a pencil, I'm going a little over, but hang in there. I wanted to finish this. We'll still get our break. Here's my plane. Notice this hydrogen and this hydrogen are on opposite side. Over here, same plane, this hydrogen are the same. Now, they can be other groups, but keep a secret in this class to always be hydrogens. Keep a secret in this class to always be hydrogens. So, what's opposite? Trans. So this is trans 2-butane. What's here? Same side of the hydrogens. That's cis 2-butane. So IUPAC, what I said earlier really is true. There are no two different molecules ever with the same name that I know of, and I don't think there ever has been. And that's the beautiful job IUPAC did. Here we have trans 2-butane, hydrogens opposite side of that red line, cis hydrogens same. And if I look at that, I went a little over this break. Well, let's take a 5-minute break and come back at 2:55. And I'll see you in 5. let's get going. First, a commercial from Dr. White. Don't forget tonight, actually late afternoon, from 5 to 6:15 on Zoom, I'll have my office hour. If you have any questions whatsoever, don't forget, stop by, say hello, and ask your questions. I'll help you out. Also, don't forget, this Wednesday, we'll do the first lab. I'll go over that. And you can download the first lab from G2L in the assignment area. If you have any trouble, let me know or come Wednesday and I'll show everybody how to do that. And labs are due the next Wednesday. So this Wednesday, we'll do a lab. It's called Melting Points, and it will be due by next Wednesday. So you got plenty of time. This first lab, it should take you about 15, 20 minutes to finish. And let's continue our discussion of double bonds. Now, double bonds, again, cis, same side, trans, opposite side. Oh, I've heard of that. How many of you heard trans fats are bad for you? And what they mean is, and I'll teach you about this later in the semester, in a trans fat, you have double bonds where the hydrogens are on opposite sides of the double bond. In cis fats, they're on the same side. Now, why does that make you healthier, or is it healthier? I'm not sure. I have some guesses, but that's not an area of my expertise. I'm not a medical scientist. I'm an organic chemist. Oh, I apologize. I didn't look at chat. And you're right, they do taste good. Even though a lot of them have been replaced, but my favorite, which I don't know, I think a while back, Frito-Lay replaced all the trans with cis fats in their potato chips. One of the most dangerous foods in the world for me is the onion and sour cream Frito-Lay potato chips. Is that stuff good? In fact, it's so good, I only buy 3 or 4 times a year. 2, maybe 3 times a year, a big bag, because it just evaporates like that. My birthday, New Year's, and the Super Bowl, I buy a big bag. Friends over, I buy a couple of big bags because they just evaporate like that. But anyways, let's get back to cis and trans double bonds. And if you go back and look at the videotape or look at your notes, you notice when I was doing alkenes, double bonds, they're always one something, one hexene, one heptene, because I didn't want to talk about cis or trans until now. Now, let's do the following. And the question is, give the IUPAC name for the following. Well, how do you do that? Well, same thing. You find the longest chain with both carbons in a double bond. And don't forget, just because they're bent like this carbon is bonded to that carbon, to that one, to that one. So that's 1, 2, 3, 4, 5, 6, 7, or one. Let's do separate color. 1, 2, 3, 4, 5, 6. So which is the larger number, 6 or 7? Hopefully you all pick 7. Therefore, that would be heptane. But remember, find the longest chain, name it as an alkane, drop the A and E ending, put E on E ending. Then which carbon of the double bond is close to the end? This is 1, 2. If I went the other way, it'd be 1, 2, 3, 4, 5. So 2 is the smaller. Now, here's something we have to consider. Is it cis or trans? When you have two atoms or groups that are the same on each carbon of the double bond, are they on the same side or the opposite side of an orthogonal plane? You can just put a dotted line here. Notice these two hydrogens are on the same side below. And we call same cis. So that would be cis 2-heptene. And as soon as I say that, this is all spoken for. Are we done? Oh no, it's your old friend, the methyl group. Let me make that bigger so I don't give anybody eye strain. And what carbon is it on? If this is 2, 3, 4, 5. So that would be 5-methyl cis 2-heptene. Now, let's go through it again. Double bond. How many carbons long is chain with a double bond? 7. Heptane. For double bond, drop the A and E ending at the name of the alkane, replace it with heptene, or E on the ending, so we get heptene. Which carbon of the double bond carbons is closest to the end? You give that the lowest number, 2-heptene. Now we have 2 hydrogens, 1 on each carbon of double bond, and notice they're below the dotted red line, the plane there. Cis is same side, trans is opposite side. And because these are on the same side, it's cis. And then where's the methyl group? On carbon 5. Everybody see that okay?
Yeah. When you say 3 points each, like what are you looking for on the answer?
When, all right, good question. Well, this would be the answer. You don't have to do any of this, but I'm showing you the thought process. So if I were to give the IUPAC name A and I show that molecule, what you would have to put down to get your 3 points, 5-methyl cis 2-heptene.
Okay. So would something be 2 points if something's wrong or 1 point?
Well, one of the hardest things, that's a very good question. One of the hardest things in organic chemistry is partial credit. In general chemistry, if you do a problem, do a lot of math, make a math error, I take off 1 point. Now, if the way I've done it is, if it's all right, you get 3 points. If it's something minor, you only get 1. If it's something major, you get 0. If the root name is wrong, it's always going to be 0. If you mess up on one of the numbers, I'll take off 2 points, give you 1 point. Because I'm not going to do 1.5 points. That would be a nightmare for me to grade. And it would be. I've seen instructors do that, and I wonder, God, isn't that a lot of extra unnecessary work? Now, I will tell you, if you've done the practice problems and done them correctly, because you've learned those 2 charts, students usually historically, and I've taught this class since 2007. Wow, I shouldn't have said that. But anyways, a number of times that ECC, if students follow my suggestions, do the practice problems, they do good, real good. Now, one thing I will tell you, the first test always has the highest average. It's the easiest of the four. Therefore, this one of all tests, you should do for all tests, but especially this one, you should study real hard because your grade is based on total points. This is the easiest one to get the total points. But you got to know how to do questions like this. I will also say, after the first test, you'll understand why I call them practice problems. Hint, after the first test, you'll understand why I call them practice problems. For those of you who know Monty Python, wink, wink, hint, hint, say no more. It's one of their famous routines. I'll let you find out what it is on YouTube. They have snippets of it. All right, have you try one. And here's one for you to try. Give the IUPAC name for the following molecule, 3 points each. And Ignacio, you understand what kind of answer you have to put down? And now you got me thinking about potato chips. The only thing worse than Lay's potato chips are Doritos. Yep. I've had French fries in ages. I like them too, but I'd rather have potato chips at home. Now, if I go out, that's a different story. God, it's been so long since I've been to a hot dog place for potato chips. I remember. It's been almost a year since I've had hot dogs and French fries. That's the one nice thing about Chicagoland. There are not as many, but there's still a number of them. When I was in college, there used to be thousands of small mom and pop hot dog stands throughout Chicago, and some of them were really good. And the chains took over, like Portillo's, which are all right, but some of those mom and pop places had much better. Or the good ones have changed. They're not as good as they used to be, like Fluky's on the north side of Chicago. And when you're done, give me a thumbs up unless you're thinking about hot dogs.
So I have you in my head now when I see the methyl. Look,
Me?
it's your
Oh,
friend
let me out.
methyl.
I didn't tell you how sneaky I am this semester. I get in everybody's heads. You know this, right? You know, methyl group. Remember I said last week, soon to be your good friend? No, it is. It's easier than when you're on long chains instead of doing an ethyl or anything. I could have, but anyways. All right, let's do this. I think everybody's done. What do we see that's different? What's not carbon, what's not hydrogen? Get your attention like that. Double bond. How many carbons in the longest chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one chain. The other chain, and it has to include both carbons, double bond. 1, 2, 3, 4, 5, 6. Which is a greater number, 6 or 9? Hopefully all pick 9. Name the longest chain as an alkane, 9, no name. Remember, for a double bond, A-N-E ending of the alkane name is dropped and it's replaced with E-N-E, no need. Next, this is carbon 1, that's 2, that's 3. I'll keep on going because we'll need that. The lead carbon here close to the end on the left is on carbon 3. We started 1 here, 1, 2, 3, 4, 5, 6. So which is a smaller number, 3 or 6? Hopefully I'll pick 6. Remember, UPAC when you're numbering a functional group carbon, always gets the lowest possible number. So I just messed up. And that lowest number is 3. Now, are we done? No, we got a lot more. If we look at the plane or dotted red line like that, notice I have a hydrogen here and one here, and they're on the opposite side. Oh, look, someone wrote something nice here. I wonder who that nice person was. Cis, same side. Trans, opposite side. And therefore, this would now be trans 3-nonene. Are we done? No, we have our good buddy, the methyl group. And the methyl group, that's CH3, is on carbon 5. So that's 5-methyl trans 3-nonene. Again, find the longest chain with both carbons, 9 carbons. Drop the A-N-E ending from the alkane name, nonane. You replace it with E-N-E, nonene. What carbon of the triple double bond is closest to the end of the chain? In this case, 3. So it's 3-nonene. Notice we have hydrogens, 1 on each carbon, double bond. They're on opposite sides of that dotted red line, otherwise known as in a plane that's orthogonal, right angle to the double bond, which is planar. And we call that opposite, trans, same, cis. So that'd be trans 3-nonene. And then what I've already gotten into your head with, the methyl group is on carbon 5. Now, let me show you something why didn't you show cis trans when you started? This you don't have to copy down. And what's the longest chain with both carbons double bond? 1, 2, 3, 4. Butane. Remember, double bond. Drop the A-N-E at the end of the alkane name and replace it with E-N-E, butene. And the carbon closest to the end of the chain, in this case, is 1. The other way would be 3. Now, here, you don't have cis-trans isomerism. What? Well, let's take a look. You need 2 different atoms or 2 different groups on each of the 2 carbons double bond. And here we have 2 hydrogens or 2 groups, in this case they are atoms, on one of the carbons of double bond. When that happens, you can't have cis or trans, because this hydrogen is trans to this one, but this hydrogen is cis to that one. So is it cis or trans? Well, can't be both, it's none. And that's why you don't see sister trans there. And that's why when I first started showing molecules, I didn't have anything there. That wasn't carbon number one, because I knew you don't have to put sister trans. Ooh. This you don't have to copy down. Remember, cis, same side, trans, opposite side. Anybody know what that is? It's transparent. Hydrogen's opposite side, transparent. I can do clean jokes in this class. That was pretty clean. Okay, but true. All right. Now, there are two nomenclature skills you should have. One is like here, here's the molecule, give the IUPAC name. The other is, here's the name, draw the molecule. One thing I should point out, a triple bond is linear. It has 2 pi bonds, and I'll talk about that when we get in 1 sigma, and you can have cis or trans. One other thing I should mention before we get into, here's the name, draw the structure. Let's talk about double bonds and rings. You can't have a triple bond until you get to a ring that I've only seen once in my life somebody did a triple bond. That was so long ago, and it was one of those papers somebody was saying, look what I can do. And everybody says, okay, whoopee-doo. It's not useful in an industry. Don't forget, I'm an industrial chemist. All right, we look at this molecule, and let me do a better ring. What do we see? A ring. How many carbons in that ring? 6. Cyclohexane. But there's a double bond. And therefore, drop the ANE ending and replace it with ENE, cyclohexene. Now, this is important. In a ring with no other functional groups, which will always be in this class, the rule is one of the carbons has to be 1, one has to be 2, and guess what? We don't put that number here because you know the lead carbon of the double bond will always be 1. So I'm done, cyclohexene. Now, what do you do when you have an alkyl group? Now here we also have a ring. It has a double bond. Therefore, it's 6 carbons. Remember, every bend in the line is a carbon. Every is a carbon. So 6 bends, cyclohexane, but double bond, ANE to ENE, hexene. One of the carbons has to be 1, and the other has to be 2. So how do we number the methyl group? Good question. You give it the lowest number, but at the same time make this methyl group the lowest. So if this carbon is 1, this is 2, this is 3. So that would be 3-methyl, 1-hexene. Now, a lot of students will say, and this is wrong, all right, what did I do different? Hold on while I close some things. I've got too much opened up. Sorry about that. I forgot to use CCleaner to clean up some of my unopened files. Everybody with me now? Can everybody see the screen? All right, now let's get back to this. A common mistake, students say, I'm going to make that carbon 1, and the mistake is they'll make that carbon 2. Wrong. See, it even says on your screen. Oh, that was hokey. Why is it wrong? Because this can't be carbon 2 with the methyl group. Because if this carbon double bond is 1, the other one has to be 2, 3, 4, 5. And if you call this carbon here 1, that would be 6. So you have two choices, 3-methyl cyclohexene or 6-methyl cyclohexene. Which gives a smaller number? 3-methyl. Now, another thing, unless you get the very large ring, and I mean large, I've only seen a couple times, in smaller rings like 4, 5, or 6 carbons, the double bond will always be cis. And because it's going to be cis, everybody knows that, so you don't put it in. So you don't see cis or trans in a ring name when it's small compared to monster rings, which we won't cover ever in this class. So for 6, 5, and 4, you do not have to put in cis. Here's one. Why don't you give the IUPAC name for that molecule? Your turn. All right, I see one person done. All right, I think hopefully everybody's done. And let's take a look at this. Oh, we've got a double bond. It's in a ring. How many carbons in the ring? 1, 2, 3, 4, 5. 5 is pentane. Remember, a ring is cyclopentane. 5. Double bond. ANE ending at the name, in this case, cycloalkane. You replace with ENE. Cyclopentene. Since there's nothing else on there, and everybody knows is one of the carbons going to be 1, it's going to be cis, I'm done. That's cyclopentene. And here's another one for you to do. And 2 carbons is an ethyl group, in case you don't know. And when you're done, give me a thumbs up. I just looked at the clock. We're almost done for today. Boy, time flies when you're having fun with double and triple bonds and carrots and tomatoes and citrus fruit. Bet you never thought Dr. White would get into carrots and tomatoes in organic chemistry. He did. And don't forget, which a lot of you have seen the first one, that if you need to, my videos for this lectures and also our labs on Zoom are on Dr. White's YouTube channel for Chem 170. Link is in my syllabus and also on D2L. All right, let's take a look at this. What do we have that's different? Double bond. It's in a ring. How many carbons double bond? One. Not in double bond. How many carbons in the ring? 1, 2, 3, 4, 5, 6. Six-membered ring. Cyclohexane, but double bond, ANE is dropped, and you replace it with ENE. And I did. Now, one of the carbons has got to be 1, and the other is 2. I'll call that 1, that 2, 3, 4. And that would be an ethyl group, CH3, CH2 ethyl group. And one way would be 4-ethyl cyclohexane. Now, another way I could possibly call that 1, 2, 3, 4, 5, which is a smaller number. Hopefully I'll pick 4. So that'd be 4-ethyl cyclohexane. Everybody with me? If not, ask questions, because remember, in my class, there's no such thing as a dumb question. And like I said, you can't in this class, and I've never seen it in the last number of decades. I shouldn't have said it that way. In a long, long time, I have never seen a triple bond in a ring, and double bonds in rings. Well, for this, we're going to stick in this class to 4, 5, and 6 carbons. All right, now, as I was saying earlier, there are 2 nomenclature skills. One is, here's the structure, give the IUPAC name. The other skill, hint, problem on a test, is draw the structure for the following. If I can spell, let's try this again. And the answer to the question is draw the structure for 3-octane. How do you do that? Well, you start from the right and move left. ENE ending, double bond. ENE ending tells you double bond. If that were ANE, octane, how many carbons? 8. Where is the double bond? Starting at carbon 3. And it's cis. So I have 1, 2. Now remember the bond angle is 120 degrees. Cis means same side. So I'll put both hydrogens on the same. Notice I have my 120-degree angle here. And by the way, I'm not going to come out with a protractor if you're off a little. And then that's 1, 2, 3, 4, 5, 6, 7, 8. And there are 4 bonds to carbon, so I know how to put in the hydrogens. And that's how you do it. Again, start from the right and move left. We have ENE ending, double bond. If that were ANE, octane, 8 carbons, where's the double bond starting at carbon 3? And it's cis, which means the hydrogens are on the same side. And here's one for you to try. Trans 2-heptene. Remember, cis same side, trans opposite side. And why don't you draw that? Then I'll do it. And when you're done, don't forget, give me a thumbs up. And when you're starting out in new functional groups, it is challenging. And don't forget, if you have any questions, feel free to come to my office hour. And I'll put out an email this Wednesday. I will be teaching everybody who shows up how to eliminate test anxiety in case you have to. But I'll cut it out of the video. And if you can't make it, come to my office hour. All right, let's do this because we're running out of time. We are. How do you determine what to draw for trans 2-heptene? Always start from the right, move left. ENE ending, double bond. If that were ANE, heptane, 7 carbons. Where's double bond? Starts at carbon 7 and is trans. Remember, cis, same side. Trans. opposite side. So I have 7 carbons. Carbon 1. Carbon 2 is going to be in a double bond. And then it's trans. So that means the hydrogens are on top and bottom, opposite side. Then I have 3. I need 7. High level math. I need 4 more. Let's see. 1, 2, 3, 4, 5, 6, 7. And I know there are 4 bonds to carbon, so I can put in the hydrogens. And that's it. All right, let's go through this once more. How do you decode this name to know what to draw? You start from the right and move left, right, left, that away. And ENE ending tells you double bond. If that were ANE heptane, hopefully you learned that table soon. If you don't, that's 7 carbons. Where does the first carbon of double bond start? Carbon 2. And it's trans. Trans, the hydrogens are opposite. Cis, same side. 1, 2. There's my double bond. Remember, I'm showing the bond angles here, which is why it's not just straight across. Same thing over here, because that way you can indicate cis or trans. And trans means if you had a line here or a plane coming out this way, think of the line that's easier for you people to think of. Notice the hydrogen is below and this one is above, opposite side, trans. And 7 carbons, and that's how you do it. Oh no. First of all, any questions on this? All right. Well, if I look at the clock, we're just about out of time, like we are. Remember, Wednesday, I will be going through in lecture on Zoom the problem set for alkanes and cycloalkanes, chapter 2. On Wednesday, I'll go through the first lab. Also on Wednesday, but I'll cut it out of the video, I will teach my method that's worked really well for a lot of students, how to eliminate test anxiety. I see students go from D's and F's to A's when they eliminate that test anxiety. And finally, don't forget, today at 5, I will have my office hour in 15 minutes on Zoom. And with that, I'm done. Gang gesund. Remember, that means go in health in Yiddish. And this I stole from Granny of the Beverly Hillbillies. Bye. Bye now. Have a great day.